Now, with all this inserting and deleting going on, something that's really interesting is what happens when our array is simply not big enough. In other words, what happens if we go to add an element at the end of our array, for example, this array E, and our array, which we know is of a fixed size 4, simply can't handle it? What do we do? Well, typically what happens in situations like this is we double the size of our array. We take our initial array, which in this case would be 4, we create a new array with a size of 8, and then we copy over all the existing elements. We copy over our A, B, C, and D. We bring them down, and now that our array is big enough, we can add that final element E at the very end in index 5. That's what happens when we resize an array, and that's also why resizing an array takes O to the n time. Now we do need to be a little bit careful in how we go about this. Let me show you what I mean. Let's say we want to do exactly like we said in the example. Let's append an E at the very end of this array. We got to be careful because we can't just go insert E at some position like 99. If we were to run that, we will get an index out of bounds exception because basically our array doesn't go up to that value. But if we use the append method, we can indeed append an F, or in this case an E, to the end of our array. What's even better now is if we go look at the documentation, we actually understand what's going on here. Here it's telling us that normally appending an element to an array is an O to the 1 operation. It's very, very quick because normally our array will have space and size to take on that new element. But in those rare cases, when we do need to resize, that's going to be O to the n. And now you understand what that means. The Apple documentation on arrays describes it like this. Here on the page of arrays, growing the size of an array, it says every array reserves a specific amount of memory to hold its contents. Okay, we understand that. We know that arrays are of a fixed size. And when you add elements to an array, that array begins to exceed its reserve capacity, the array allocates a larger region of memory, doubling the size of the array, and copying its elements into that new storage. The new storage is a multiple of the old storage size, and this exponential growth strategy means that adding an element happens in constant time, O to the 1, averaged over many operations, but appending operations that trigger a reallocation or a doubling the size of the array have a performance cost. And that's where that O to the n linear time comes in. So that's how resizing an array works. Now you know some of the magic that goes on behind the scenes. Let's quickly just review what makes a couple of things about Swift arrays different.